Welcome students. We come back again with a new video in my classes. That is, my name is Suman Mukhopadhyay and welcome to my channel Suman Sir Classes. So today we discuss about the part that is the capacitance. Okay, the new topic from the electrostatics that you know. So capacitance, in these topics we also discuss the various things, that is capacitance, its dimension, its SI units, and what is the main formula of the capacitance of a capacitor, and also describes the different cases, that is the parallel plate capacitor. And once more again, that is parallel plate capacitor. When we solve the parallel plate capacitor, a maximum times a problems appear. That is, for parallel plate capacitor, electric field is sigma by epsilon. But what way it may appear, you don't know. So don't worry about it. In this video, I will describe everything. Okay, so no problem at all. Just check it out. So first things, that is the capacitor. What is capacitor? So generally, we know that capacitance means that is the storage capacity. Just simple explanation that you know, that is the storage capacity or whatever. Okay, so when we explain with the capacitor or capacity, just consider you have a bicycle, okay, and within these tubes, when we maximum air can passes within these tubes, its volume increases. So more air passes within these tubes, more volume increases. So volume and the air, okay, so that these are proportional to each other. So same thing, consider a charge storage span is present. Here the two plates are present. Here you just stored certain quantity of charge. So Q amount of charge is stored over there. So more amount of charge when added together, that is more amount of charge. Okay, when we added together, more amount of charge. That is, you charge with a positive charge. So more amount of charge is added together, therefore its potential increases. Potential you also discussed in the previous video, that is Q proportionality V. So when Q proportionality V, this may be appear, that is Q and V, these are proportional to each other. That is, what is the meaning of it? That is, more amount of charge passes to the plates, that is more amount of charge stored within these plates. Therefore, potential of these plates is also increases. That is Q proportionality V. So Q proportionality V, so we just write some proportional sign to the equal sign, you get a constant. So this constant written in the form, that is C. C is called the capacitance of the capacitor. This one, capacitance of the capacitor. Okay, so Q equals to CV. So when Q equals to CV, that is Q is the charge, C is the capacitance, V is the potential. So that means C equals to Q by V, this one. So when C equals to Q by V, this one, so Q, what is Q? So now we come to the points. This is the C and Q, that is written in the form, that is in SI system, that is the coulomb. Okay, so we just write this one is coulomb, C, and V, what is V? That is equals to volt. If I consider 1 coulomb of charge added together and potential increases 1 volt, then the capacitance of this capacitor is called the 1 farad. So what is the SI unit of the capacitor? That is the farad. It is written in the form. So SI unit is farad. Understood? Now it is clear. So now SI unit is farad. Now we just write the certain relations related to the farad and others. Consider you just have a capacitor that is 1 farad. Okay, so no problem at all. But when the value is very less, something consider. So we just remember when we want to solve the different type of numericals, this type of problem it may appear, that is the microfarad, picofarad. Now question arises in your mind, say what is microfarad, what is picofarad, what is this? So we just explain in this case, that is equals to, first of all, microfarad. Okay, so first things, SI unit is farad. So 1 microfarad, this one written in the form, that is 10 to the power minus 6 farad. This one, 1 microfarad. This is much smaller than farad. So 1 microfarad equals to 10 to the power minus 6 farad. Same way, 1, if I write 1 microfarad, 1 microfarad means 1 microfarad means this is picofarad. Okay, so 1 picofarad or 1 microfarad. 1 microfarad 10 to the minus 6. So micro 10 to the power minus 6 that is 10 to the power minus 12. So in this form that is 10 to the power minus 12 farad. So in this way we can solve this part, that is at first convert into the microfarad or picofarad, whatever, that is picofarad present, so we just convert it into the farad. Okay, that is in the SI system. After converting this, you can solve any type of numerical problem, that is do with the capacitance. So 1 microfarad that is 10 to the minus 6 farad, 1 microfarad or picofarad that is 10 to the minus 12 farad. This one is the SI unit in this case. Okay, now we come to the points, that is the dimension. So C equals to Q by V. Q is the coulomb. So this one written in the form, that is coulomb per volt. Okay. So what is volt? Volt equals to joule per coulomb. So we just write here, that is coulomb joule per coulomb. This one. Okay. Because 1 volt, that is 1 coulomb by 1 volt. Okay. So 1 volt, this one written in the form 1 joule per coulomb. Okay. So that means that is coulomb square by joule. Okay, so joule, that means so what is joule equals to? It may be also written in the form, that is coulomb square Newton meter, because 1 Newton into 1 meter, that is equals to 1 joule. So we just write, that is 1 farad equals to, it is also, that is equals to coulomb square per Newton into meter, this one. So this is the conversion, that is from the farad to the coulomb square Newton meter. This is the SI unit. So coulomb square Newton to the power minus 1 meter to the power minus 1, this one. This is the 1 farad and it is written in the forms. Okay. Now we come to the point, that is the dimension. What is the dimension? So C equals to coulomb square Newton per meter. Okay. Coulomb square, coulombs means that is the charge. So what is the charge? Charge equals to A into T. Okay, that you know, we discussed in the previous video. So AT square. What is Newton? Newton is the force. Force, that means A ml T to the power minus 2. A ml T to the power minus 2. And what is meter? Meter is, that is the length. So length in this case we just write, that is simple L. Okay, so just check it out. There is M, move in the upward, so M to the power minus 1. Okay, L into L. This one written in the form, that is L square. So L to the power minus 2. That is A square. Simply minus 2, it is moving in the upward. This one is plus 2. So that is equals to T to the power 4. That is M to the power minus 1, L square, A square, T to the power 4. So this is the dimension of the capacitor. So we just recapitulate this part. Capacitor, that means capacitance means, that is when a charge stored in this parallel plate or anywhere, so that is the potential increases. So Q proportionality V. So Q equals to CV. Okay, so C is called the capacitance of the capacitor. So it can be converted generally capacitance SI units is farad. Okay, farad equals to coulomb square per Newton into meter. So SI unit is farad. So 1 microfarad equals to 10 to the minus 6 farad. 1 microfarad. This means 1 picofarad. Picofarad equals to 10 to the minus 12 farad. This type of relations is very much important, and also this one is the dimension in this case. Okay. So now we discuss about the parallel plate capacitor. Okay. Okay. So now we discuss about the parallel plate capacitor. So what is parallel plate capacitor? Now we discuss main things, that is the relations, that is the electric intensity for the infinite parallel plate. All these things in one video. Just like that. This is the P. P is the parallel plate. This one. P and Q both are the parallel plate capacitor. Okay. This P is charged with positive. Consider we added some charge, positive charge within this. Okay. From the other side of Q, it is connected to the ground. This part is ground. So there is no charge present on that side. So when it is added to the positive, so inside portions of the plate Q, it is negative charge will appear automatically. So that means additions of positive, negative charge will appear. But opposite side of the Q, that is connected to the ground. So all this charge passes to the ground. So there is no charge accumulated over there. We just repeat once again. So this one positive P plates, and this one is Q plates. These are parallel plates. Okay. Now the distance between these plates is D. We added some positive charge within these plates. When this is positive charge within these plates added, so therefore a negative charge induced on these plates Q. Okay, but other portion, the opposite side of the Q, it is connected to the ground. So no charge accumulated over there. And the distance between these two plates is D. Here we consider. So now the question arises, what is the electric field at any point? This is positive, this is negative. So therefore, huge number of electric field, that is electric field is acting along these directions from P to Q, because positive to negative electric field acted. So this one positive to negative electric field acted, this one positive to negative electric field acted. So positive to negative electric field goes on. Okay, this one infinite parallel plate, this is also infinite parallel plate. So these are placed at a distance D. Now what is the electric field in between them? That is any point between them, P and Q. Now this is the main questions. Now in number of video in your books, you just observe that for parallel plate capacitor, the electric field E, its value is sigma by 2 epsilon 0. It is written over there. Okay. Now what way it may be appear? So this is the main questions arise in your mind. Sir, what way this can be? A number of students ask me about that. That is, sir, what way sigma by 2 epsilon 0 is appear? Now this is the main things. So now we discuss what way the sigma by 2 epsilon 0 it may appear in this case. Just consider about this. Consider this one is the infinitely plane, A, B, C, D. This one is infinitely plane. Okay. So we just want to find out the electric field at any point, at point P or at point Q, whatever. Okay. So that means electric field always, this is charged. Obviously this plate is charged. When the plate is charged, therefore number of field lines emitted along in the outer directions. Okay. This within the certain area, it is called the within the certain area, it is denoted as the flux. So we just want to find out the total flux. Okay, let me explain in this form. That is, consider this one is that. So this is the electric field, okay, and this is the infinite plane, and this is the, we consider a cylinder, okay. Cylinder passes to the center, this one, okay. This is the first terminal. This is, if I consider this is placed at the middle, so it is divided into two parts. This one is R. Consider this one. This length is also the R. Okay, so just think about it. This is the external portions. Okay, the radius of this part, this is considered the R. So what is the area? In this case, this area is considered the S. Total area in this case, we consider this one is S. So this area is considered the S. So this one is S. Okay, so S is the total area. So the distance between them, that is the parallel plate and the another end, this one is R. This one is also R. Okay, so electric field lines just emitted in the outward direction, just like that. So because this is the charge plate, so number of electric field lines are emitted from this surface. Okay, we just found within the cylindrical surface from this end number of electric field lines emitted. We just want to find out. Okay, electric field lines, that means flux, generated flux. So same this opposite end number of electric field lines emitted here. So we just calculated here what the total electric field lines. Okay, from consider this one is the P surface. Okay, this one is the P surface. So total flux in this case, flux equals to, you know that is electric field into the total area, that is surface integral S into E dot ds. Okay, so D dot ds in this case electric field acting in the outward direction. Okay, electric field acting in the outward direction, and the area also perpendicular. In my flux, in a video before flux, we explain about this. So that means the area ds, it is also acted in the outward direction. Area acted outward direction, electric field acted at outward direction. What is the angle between them? So E dot ds, that is equals to E ds cos 0 degree. So what is the value of cos 0? That is 1. So it may be written in the form that is E into ds. Simple. If I integrate over the surface, S, then this value is E into S. Okay, now it is clear. So total electric flux linked with the surface, this surface, that is equals to E into S, because total flux equals to E dot ds. Now ds over the surface, this one is can be written in the forms, that is E dot ds equals to E ds cos 0 degree, because electric field and the area, both are acting in the outward directions, okay, in the same directions. So that is the cos 0 degree, that is equals to 1, that is E into S. So total electric flux in the outward direction, that is equals to E into S. Same thing from the opposite side, that is the Q surface, it is the electric field emitted. So total flux linked with it, that is equals to E dot ds. Same thing, that is the total E into S. So therefore the total flux in this case, that is phi equals to ES plus ES, that is equals to 2ES. Okay, so these 2ES, according to the Gauss theorems that we know, that is 2ES, that is equals to, that is the total flux. So flux phi equals to 2ES, that is equals to Q by epsilon naught. Okay, total charge by permittivity of free space. Now what is the total charge? Total charge equals to sigma into S divided by epsilon S. Epsilon is not, so SS cancel out. So that means E equals to sigma by 2E. Okay, so that means if I write in this case, that is if I want to find out, that is the value of the E. So E equals to 2 into epsilon, sigma by 2 into epsilon naught. Okay, so this is the value that we obtain. If I consider that is infinite plane, that is the electric field in front or back side of the plane, that is equals to sigma by 2 epsilon 0. This is the main target. Okay, now the concept is clear. That is, if I consider the ABCD is the infinite plane, in front of it, that is the electric field process, that is equals to sigma by 2 epsilon 0. So here we consider the point B. This one is the point, this one is the point, that is equals to B at the any point. Okay, so at this point, due to the plate P, due to the plate P, okay, the electric field, that is equals to sigma by 2 epsilon 0. Same thing due to plate Q, the electric field, that is equals to sigma by 2 epsilon naught. Okay, so both these 2 epsilon naught, so total electric field at this P points. Okay, so now total electric field, if I consider total electric field, okay, so what is total electric field? That is equals to sigma by 2 epsilon naught plus sigma by 2 epsilon naught, this one. When we add it together, we get the value that is equals to sigma by epsilon. Now it is clear. Sigma by 2 epsilon naught is the electric field due to a one plate, and sigma by 2 epsilon naught is the electric field due to the other plate. So if I add it together, so we get the value of the sigma by epsilon naught. This is the total electric field. If I write in this case, the total electric field in this case, that is equals to sigma by epsilon naught. Okay. So now what is the dV? That you know the relations dV, that is the total potential. If I consider the small amount of potential, that is equals to dV equals to minus E dot dr. Okay. Now just simple explanations. Consider here at the center, we consider the point B. Okay. At the point B, if I place a unit positive charge, just listen. If I place a unit positive charge here, so for this one positive, this one positive. Okay, so positive repulse each other. So that means electric field acting in the outward directions. Okay, now this unit positive charge, if I want to move this unit positive charge towards P, that is the charge body is moving in the opposite direction. That is the dr is in the opposite direction. Okay, so electric field acting in the positive forward direction, but the charge moving in the backward direction. So what is the angle between them? 180 degree. So we just write this is a dot product. So that means E dr cos 180 degree. So this is the value. Now cos 180 degree. What is the cos 180 degree? That is the minus 1. So that is minus plus. So simply E dr. So dV equals to, this is the value written in the form, that is equals to E dr. Okay. Now we come to the points, that is the dV in this sense, that is dV equals to E dr. Main things, the total value of the electric potential, that is equals to E dr of this. Okay. So we just want to find out the total potential. So what is the total potential? Total potential means that is V integrations, that is V equals to integration of 0 to V into dV. This one. So 0 to V into dV, that is equals to, again we integrate over there. Here the total potential occurred due to this distance, that is the D. So 0 to D E dr. Okay. What is E? That is the electric field. Electric field value is sigma by epsilon naught. So we just write here. So that is sigma by epsilon naught integration of 0 to d into dr. Okay. So after we integrate, we get the value that is equals to sigma by epsilon naught integration of 0 to d. So this one is simply d. So this gives the value of the potential. Okay. So this gives the value of the total potential, that is equals to sigma by epsilon naught into d. Okay. Now what is the sigma? The sigma in this case, that is written in the form, that is the charge per unit area. Now so sigma, if I write sigma equals to charge per unit area, that is q by a. Okay. So therefore the v equals to, if I put in the value of sigma, in this case v equals to sigma by epsilon 0 into d. So that means v equals to putting the value of sigma, that is q by a into d by epsilon naught, this one. Okay. Now so what is the capacitance? Capacitance C equals to q by v, that you know the relations. Okay. So q, what is the value of v? That is qa qt by a into epsilon naught. So that is q cancel out, that is a into epsilon naught by d. Okay. So this is the value of the capacitance. So capacitance of the capacitor, that is equals to a into epsilon naught by d. Okay. So this is the capacitance of the parallel plate capacitor. So within this video we discuss the parts, that is a parallel plate capacitor, what way the electric field due to an infinite plate is sigma by epsilon 0 appear. We also discuss in this case, and also the derivations of the potential for the parallel plate capacitor, and also find out the capacitance. By using this formula we can solve different type of numericals related to in this case. Okay. In my next video I will discuss the different cases due to the parallel plate capacitor, that is the dielectric medium and others cases also. Okay, and sharing of charge is another part. So again we just think about that. We just take a note all these things about that, and read your exercise, read your book carefully and very much carefully, and solve your numericals problem. Okay, and watch my video and subscribe my channel. So thank you again. We come back again. Thank you.